Now we'll see a problem based on Ohm's law. Now you can see the circuit here. In that circuit, you can see that the X and Y, we have to find the potential difference between the point X and Y. Now you can see in the next, I have drawn the same circuit, but only I have named it the branch A and AB, and this is the CD. And you can see in between A and B, there are two resistances, 2 and 3 are in series. Therefore, we can find a equivalent resistance between AB as 5 and between CD as 6 plus 8 is equal to 14. That I have shown here. Between AB is the equivalent resistance is 5, and between CD the resistance is 14. Now you can see that the resistance 5 and 14, they are also in parallel. The current I, the main current through the battery I, is divided into two parts. One part goes to AB, another part goes through CD, and these two current again combined and come back to the battery, flowing through the battery. Therefore, the branch AB and CD are in parallel. Therefore, we can find the equivalent resistance. Now, as we have discussed, the equivalent resistance, to find the equivalent resistance, if it is the equivalent resistance is R, then 1 by R is equal to 1 by 5 plus 1 by 14. If we make the calculations, and R is to be found to be 3.68. Therefore, this 2, 5 and 14 is replaced by their equivalent resistance 3.68. That this circuit, it represents the equivalent circuit is this. Now you can see the current flowing through a battery is also flowing through 3.68 and also flowing through resistance 4. Therefore, this resistance 4 and 3.68 are in series. Therefore, we found this equivalent resistance at 7.68. And then we can find the current I through the battery by dividing 10 by 7.68. Therefore, that I am showing here. The current through the battery is 10 divided by 7.68 is found to be 1.3 ampere. Now we have to find what is the potential difference between A and B. Now, if now we come back to the original circuit, we take the negative terminal as 0 potential, then the positive terminal is of 10 potential. Therefore, the potential at A is 10 volt, and the potential C also the same 10 volt. Now, as we found out that current I is flowing through the battery, then we can find the potential difference as potential difference as 1.3, and the equivalent resistance between A and B, and which is found to be 3.68. If we multiply, then the potential difference between A and B to be found out. Therefore, if we come to the original circuit again, therefore potential difference between A and B is already found 4.78. Therefore, here potential will be 5.22. Therefore, difference between 10 and 5.22 is 4.78. And already I told the potential at A is also C is also 10 volt and D is 5.22. Now the current is flowing through 1.3 ampere through the battery. And how it is divided? How it is the current divides into two part, and that we have to find out by the potential difference between A and B divided by equivalent resistance. That means 5. That we are doing here. That you can see the the branch current through the branch. What is the potential here? What is the potential is the VAB is 4.78 divided by the resistance between A and B, equivalent resistance between A and B, which is 5, and the here it is 4.78, and therefore the current through the branch AB is equal to 0.96. Therefore here current through the AB is point, you can say 0. Current is flowing 0.96, and the remaining current will be flowing through the other branch. Therefore here you can say it is 0.34 ampere. Now 34 ampere. Now we can find the potential at X. Now we can find the potential at X. This is the X. We can find the, how to find 10 minus the 0.96 into 2, and potential at Y 10 minus 0.34 into 6. That we are doing here. You can see here potential at X. Here we can see here potential at X 10 minus 2 into 0.96 is equal to 8.02. Potential drop at resistance 2. Now exactly in the similar way, potential at Y, this is 10 minus 6 into 0.34, and it is found to be 7.96. And X, potential at X is 8.08, and potential at Y is 7.96. And if we subtract, then this is the potential difference. Now all the potential, one thing I have to tell you, that all the potential we are telling, the potential at X, potential at A, everything in comparison with the negative terminal of the battery as grounded. That means at zero potential. And that is the complete solution of the problem.